Hello everyone, I am Anand. I welcome you all to this course on computer-aided drafting, that is CAD, through AutoCAD software. It's a very popular 2D drafting tool that is being used widely world over, and I'm glad to have you all in this learning platform. So moving forward, what do you get out of this course? What are the skills that you acquire in your portfolio? This is what we look at. So the prime skill is the two-dimensional drafting skills. So we'll look into what 2D is all about and how AutoCAD helps us, but this is a very key primary area that we'll be focusing on. Because once you're familiar with 2D drafting, you can expand that skill set to 3D and henceforth. Because now almost all the design industries directly model the 3D models and take 2D drawings out of it so that they can productionize them. So this 2D is a very needed fundamental for each and every engineer out there. It can be a mechanical engineer, automotive engineer, but also an electrical engineer who can use these drawings, these plans to create wiring harnesses and PCB diagrams and so on and so forth. And this AutoCAD has been heavily used in the civil domain, wherein they use this for creating site layouts, creating quantitative drawings, and measuring site plans or all those things. So it's an extensive tool set that you'll be using. Then we have the all more important geometric dimensioning and tolerancing skill. This is a very important skill set that each and every engineer uses in the practical domain. Actually, this is more important because most of the issues created in the production line or in quality arises out of wrong tolerancing or wrong dimensioning techniques, because the desk engineer, that is who creates this drawing, needs to understand how the component is being machined or produced so that it arrives at the final form that he or she designs. A casting technology will have a different tolerance, whereas a 3D machined component can have a very minute tolerance support. So tolerancing is nothing but the margin of error, the machining error that a tool can produce a component to. So we'll dwell a lot on this in subsequent weeks. We'll focus more on this so that you'll gain practical skill sets to employ these techniques onto your drawings. And then we have the file management techniques. In most of the courses, you won't get to know how you manage the files that you keep on creating, the design files. The general practice when we create files is that we'll name it as file 1, and then sometimes we overwrite it or sometimes save it in a different location. Or if we keep on working on it and deem that this is going to be the final one that I'm going to publish, then you rename it as _final. But then there comes a small revision to it, then you rename it as _final, final. So it goes on and on. So when you look back those files, it's difficult to review which is what and when it has been revised, why it has been revised, and what should the version I should refer to. So these questions arise out of. So this is a proper hygiene that we look into. How can we name the files, store them, retrieve them, and process them? So this will help you a lot on the due course of time when you start designing or modeling your creations. And then you have the project management skills. We'll ponder upon this during the last week course, because once you're a proficient 2D drafter and also 3D simulist, then how do you take forward the design from the inception, the conception stage, to the final product? What are the challenges involved in it? How do you plan for the risks? How do you take contingencies in the process? So let's dwell a lot on that. So at the end of this course, you will be familiar with these 2D drafting techniques primarily through AutoCAD and have a sound knowledge on geometric dimensioning and tolerancing skills, and also have a fair view on file management techniques, and then a very sound structural knowledge how to handle a project and how to handle different stresses. In this course, we have 12 core contents. Each core content focuses on a key area that you would face in the industry. Each week has a course content of 2 hour sessions each, and for each of the weeks you'll be having different assignments. That'll be assignments grouped together or individual one, but that will test your skills to make sure you have understood the concept very clearly and can able to apply them at a very faster rate and with minimal errors. So this will help you practice your skill sets to achieve the level of perfection that you have set targets on. And finally, you'll have a capstone project which will combine a lot of different techniques that you have learned throughout the course. It will be a challenging one. So at the end of the capstone project, you can take with you a rich knowledge of how you have applied this technical know-hows of AutoCAD 2D into a practical one. So this will enhance your confidence level and also a very good demonstration of the skill sets that you have acquired through a lot of hard work that you have put into this course. So splitting on to the week contents, in the first week we introduce you to the basics of drafting and also through the different CAD technologies that are available and how it has evolved, and also look into the brief of AutoCAD system and brief on the drafting fundamentals. So this we have named as course Preamble. And next, which way? Lay of the land. That is, once you are familiar with the basics of AutoCAD drafting techniques, you have to understand how you can change the viewpoints, explore the drafting, a zoom or a pan. So those kind of techniques where you can manipulate the screen so that you can approach the drawing much effectively is what we'll look into in week 2. That is, which way? Lay of the land. Exploring AutoCAD interfaces for drafting settings and specifying the dynamic inputs, specifying the limits, the units, and also looking into editing fundamentals such as a move command, copy, array, and so on. So next we have the action part, because once you have ready the framework, what you have to do, then executing them. So in here we have something called as a steering wheel, a navigation techniques that AutoCAD has into it, wherein you can do all the manipulation techniques into this. And also once you're starting and proceeding with lots of dimensions, lots of drafting tools into it, then you have to select a few and then edit. So we'll look into those techniques, selection techniques, where you'll look into box technique, fencing, multiple and single select, and so on. So next we have something called as amend. Amend is another word for editing. So once you have started creating your 2D drawing, of course you'll have to edit a lot. So editing does not mean correcting alone. It means creating a new dimension or a new feature from previously available drawing features. We'll look into it more, but the techniques what we'll look at it is using stretch command, extend command, trim command, and so on. So this will help you to work faster and more better way so that you can bring structures to your design ideas. And also we'll look into the other editing techniques where you will enter the text commands and edit the style, color, line type, line weight of your drawing so that you can give another dimension to it. I mean dimension as in the visual dimensions that you can give into your 2D drawing. Differentiate between different areas in the drawing. So we'll look into more on that in this amend section. Next is a very important area in the domain of mechanical industry, that is in manufacturability. So here the techniques that we look into is creating of hatching, the plain fillet, chamfer techniques and all. So hatching means the internal cross sections of how it look into. So these are very key to make the designers understand that how the assembly is going to come into, and also it helps the assemblers, that's the line executives, to understand where the fillets are and how they should do the assembly and all. So why this fillet and chamfer comes in? Because two components that are going to mate together to come together as an assembly and serve a different function. So these chamfers, fillets are very important to make sure they have the proper interfacing techniques. So those techniques, that is the fillet, chamfer and all, we'll look into the manufacturability area. And also we'll look into key inquiry techniques, wherein we'll measure the distance, the radius, angle, etc. in this segment. Next, we'll learn it as the quality assurance one, wherein we'll ensure that the quality is met through the drawings. As we had discussed earlier, this quality means the geometric and dimensioning techniques, and also we'll look into how we can dimension our drawing. And the same gets continued to the next section, where we'll look into more quality and management tools, and also a little bit on file management techniques, and also we'll look into the tolerancing, leader, multi-leader and dimensioning edit techniques. So next we'll focus on productivity enhancement. How well can you work around your way with the drawing? Because as and when your drawing becomes complicated, you have to be using advanced techniques so that you can deliver the results very quicker. So towards here we'll look into blocks and geometric constraints and also working with layers. So this will make sure you stand ahead of your peers and deliver good and quality drawings. So next, once you have created drawing, how to demonstrate it to your team and make sure others are benefited out of it. How do you collaborate effectively? So here we'll see into how can we use external drawings and use it that value addition to your drawings or supporting your drawings to other projects and so on. So we'll go for external referencing, and also we'll look into AutoCAD Design Center tools and also the explode function. So next, what we have here is once you have collaborated and then publishing your work, broadcast dive work. So here we look into the plotting techniques. Plotting is nothing but generating printable drawing views that you can publish out, and we'll also look into the different plot style that you can use, and also we'll give out a brief on the capstone project that you have to work on. So you'll start working from your week 10 onwards and focus on week 11 and 12 parallelly on working on your capstone project. So next we'll look into how we can work smarter. So here we'll look into different layout management techniques, model space and paper space terminologies that AutoCAD uses, and also how to effectively use floating viewports. And finally, in the epilogue session of this course, we'll look into the project management techniques that each and every one of you need to be familiar with so that you can support your team effectively. And also we'll look into again a brief on capstone project and support you on that. So with the brief on syllabus, now let's move forward to this course week on the preamble session. And in week 1 we'll cover the following topics: the drafting technique, what it's all about, why drafting is required, and what are the different technologies that people use to create the draftings. And also we'll look into what our orthographic projections are about and how to visualize the 3D models into 2D layers. And next we'll look into the CAD, that is computer aided design, how it has evolved and where it is now. And finally we'll look into the AutoCAD software brief, the working space, where are the tools located, how to work around with new files, creating and saving them and all. And next we'll also look into key techniques, drafting techniques such as creating a line, a circle, arc, ellipse, usage of erase command and also the oops command. And the next we'll look into a brief on the assignment, how we can go about and what are expected out of your assignments. So now coming to why a technical drawing is required. What do you mean by a technical drawing? What is intended out of a technical drawing? So a technical drawing typically tries to answer the 5W and 1H. So what are those basically? The first W is what? So what is this drawing? What's the purpose of this drawing? What is it intended to tell to the manufacturer or the designer or whomsoever? What is the purpose of the design that you're putting forward. The next W is why. Why do you need that drawing? Why do you need that function? So this drawing describes that. Next, the drawing also describes who is the designer, because this is a very key area that most of the people miss out. But in industries, many people work on a common project, so we need to track of who has designed and how it has evolved. That is, how it has been modified by whom, the originator, the modifier, then the publisher. So all these details need to be captured. Next is when. So when was this drawing actually first published? What are the revisions it has undergone? Is it the final one, or is it a pre-final stage, or is it just in the nascent stage? All this needs to be captured in the technical drawing. And next, where. Suppose you have different offices in your industry, wherein maybe the same domain is spread across different locations. Then you need to keep a track of which drawing originated from where, so that it will help you to organize them and monitor them effectively. So now, answering all the 5 W's, then move on to 1H. That is how. How do you manufacture the component? Those kind of data, the instructions are embedded into this technical drawing. So typically, a technical drawing needs to answer all those things. So now look closer to the image that is here. So what do you infer out of this? This is where a detailed technical drawing comes into. Actually, this is the creation of Leonardo da Vinci. Helicopters. This is a way back. He's a very rational design thinker, so he has actually drafted this. This helicopter uses cloth or a very light material, a filament that used to create the lift, but actually it was not conceptualized or not able to productionize at that point of time. But recently many individual scientists and local DIY innovators tried doing it, and they were quite successful in doing this. But the point is, this drawing is very vague. What material should I use it? How much the entire size should be? What is the dimension ratios? With that, this image is very difficult to draw in those details. So this is where a technical drawing comes in. It will help you answer all those 5 W's and 1 H, and so it can be easily reproduced and worked upon. But again, Da Vinci is of course the king of designs. Okay, moving on. Have a view of this drawing. So here you can see, even though it's in a different language, it's in German base actually, but with the different views you can make something out that is kind of a burner that uses some logs, and there is some chimney, there is some vents, there are some areas where you can put the charcoal in. Okay, so you can infer some amount of information out of it. So this is what we were speaking earlier. A technical drawing must help the productioner, the manufacturing area, or the other designers to understand a language, a technical language, and replicate them. So this is one such example of where a technical drawing can help you out. This is another example of how the technical drawing can help the manufacturing domain or the industry. So this is actually a fighter aircraft from the World War II generation, a German fighter aircraft. It's called the Me-109G2. So this drawing typically shows you how to assemble this vehicle and which components it's where. You have the gunner area, you have the propeller area, and also there's a detailing on how your profile section varies at different locations and how are your instrument clusters positioned, all those things. So a technical drawing helps you to understand how to put things together. So now let's look into drafting fundamentals. Having understood what is a technical drawing, let's see what a technical drawing literally means. Wikipedia states that a technical drawing or drafting is the act and discipline of composing drawings that visually communicate how something functions or is constructed. Because if you can recollect, we were talking about the same. We were talking how the designer conveys his idea through visual media. That is, through drawings. How do he convey that drawing is intended to satisfy a function, or how it is manufactured or assembled. So that is the crux of a technical drawing. The ISO name, that is the International Standards Organization name for this drafting, is technical product documentation. Documentation means that you're storing it for ages to come. That is, you're indexing it, you're properly locating it and then storing it. So that is where this drafting comes in actually. So as we discussed earlier, it is a two-dimensional information and it is language independent. A technical drawing can work across geographies provided they all have a common understanding of what a technical drawing is. They need not understand the metrics, the units, but still based on the instructions that are provided in the drawing, they can translate and then effectively visualize them. So a technical drawing is heavily language independent because it's a language, it's on its own. So next, they are bound by rules or standards. That is, you have to draw a line of this thickness only for a normal line, and a construction line has to be drawn in such a way that it is replicated the same throughout the world. And what paper sizes that you use, you have A4, A3, A2, so that it is the same everywhere that is being employed. So this technical drawing is bound by rules or standards that will make sure it is language independent, and it also houses a wealth of information of 2D data. So to sum it all up, a technical drawing conveys the geometry of the design, the dimensions of the design, the tolerances of which it has to be manufactured, and what is the material it's going to use, and what is the finish of the design once it comes out of the line. So next is, what are the different viewpoints? This is a very popular drawing or a cartoon that will tell you that even though the object is the same, based on different planes of projection, that is based on different views, it will give out different information. That is, here you can see a couple of scientists who are experts on their own domain construct the visual image of the object differently based on the plane of projection that they have. That is, each and every one of them have a different point of sights and viewing methodology, that is the ray of sights. So they term the object, that is here the elephant, as a spear, a tree, a wall, a rope, because it's keep on deviating from the viewpoints. So reiterating, a technical drawing, as spoken earlier, has to be language independent, has to be very strong with 2D data. Then how do you convey those data in a structured way? So that's where you have the orthographic projections that are being used in drafting techniques, wherein you will keenly define what the object is, as seen it's located in the center, and next you define what is the plane of projection, that is, on which plane do you see the projected image to it. So here you have different planes of projection. You have the horizontal plane, you have the vertical plane, and also you have the picture plane. So the same object, when it's moving on to a different planes, how it's been visualized. And next is the point of sight. From where do you look this object from? And what are the rays of sight? Because you might have learnt about this perspective view, wherein if you see a railway line, a railway track, basically, even though they are parallel to each other, based on your viewpoint and the rays of sight, they will tend to merge at some location. So that's called a perspective view. But in orthographic projections, as your rays are parallel to each other, they never converge, because basically you have these lines are parallel to each other, and as your rays are parallel and your point of sight is at infinity, you'll get a perfectly parallel view. So this is called the orthographic projections. So if you understand this language of orthographic projections, you can visualize the 3D object into different 2D planes so that everyone can visualize the object effectively. To give you a further example of how the orthographic projection can work in, take a view of this butterfly valve. So you have 3 dimensions that you can look into. You have the X dimension, the Y and the Z dimension. And if you're considering a viewpoint from here to here, and so this will be your front plane, that is in front of you, standing here and viewing this object, and so the plane is this one, the Z and X plane that you can see here. So the object will look something like this. So this is your front view. And next, if you go underneath to it. That is, you look the object from below, and through this plane X and Y, you will have this. You are looking at the bottom view of the object. As you can see, only the bottom side and the remaining part of this handle here. Next, if you are seeing from the top, that is viewing at the same XY plane but from the top direction, you have something like this, wherein you can get the detail of how the handle sits into here and where is the bolting structure, how is the plane view and all this thing. Next, you can view from the right and left hand side also. So that will show you how this flap is located, what is the angle of it. So if you come to the right side and view, this is the plane here, and you come to the right here and see through this, this is how it will look into. And if you come to the left side and see it, and this is how it will going to look from the left side. So now you can visualize all these views together to visualize the 3D view of this. So this is what you are intending to do with 2D drafting. You are essentially going to convert this 3D model or a 3D design into separate 2D drawings so that the designer, the drafter, the assembler, the manufacturer, everyone can understand that once they have machined in putting together all these views, they'll get this final component. So this is the power of orthographic projections, wherein you break down the 3D model into separate 2D models. So now you can also see one thing. We have spoken about the left view is actually on the right, and what we have spoken about the bottom view is on the top. So we name it as the first angle of projections. So it means that in a 4-quadrant plane, we take in the first quadrant, that is this quadrant, we keep the object on top of it and view on the respective planes. So that's called the first angle of projection. So it's been represented by this symbol. In certain countries, wherein in UK and US, they use the third angle of projections. So the visualization is the same, but the thing is they look into the third plane of the space so that your left and right will stay in the same location. So that is, the left view will stay in the left, right view will stay in the right, and the bottom on the bottom and top on top, and so on. So that's called the third angle of projection, and there you will have this view interchange between these two. But in India, we predominantly use this first angle of projection. So this will give you a fair idea of how the images are to be positioned. So this is what we are speaking about. Based on the standards, you have to follow certain standards so that if you put in this symbol, it is understood that you are always referring to the first angle of projection, and hence this image is always the right view of the 3D model. Hence you have to be very careful on communicating that this is actually the first angle and putting the views correctly in that their respective locations.